All right, so today we're going to keep working on finding the center and radius of circles when the equation is written in different ways. We're going to start with what we talked about last week, these perfect square trinomials. So remember that if you have a trinomial, remember a trinomial is a little expression like this with three terms in it. Tri means three, so x squared is one term, 2x is another term, 1 is another term. Because there's three of them, we call this a trinomial. Now, as long as your trinomial follows a certain pattern, we call it a perfect square trinomial because it can be written like this. And this is really helpful when we're writing equations for circles. Now, that pattern is that whatever this middle number is, the one with the x, so here it's a 2, if you take half of that, so 1, and then you square it, 1 squared, you should get the last number. If that's the case, you can write it like this, where this number is half of that. And that works, we know that, because if we take x plus 1 squared, we know x plus 1 times x plus 1 squared is really x plus 1 times x plus 1. So you can write x plus 1, and do this little box thing that you learned in algebra last year. So x times x is x squared, 1 times x is 1x, 1 times x here is 1x, 1 times 1 is 1. So these two 1's out here create these two 1x's in here, which adds to be the 2x. And then this 1 times 1 gives you this one right there. The same thing works here. Because half of 6 is 3, and 3 squared is 9, you can write it like this with that x plus 3, where this number is always half of that number. So that would look like this, x plus 3, x plus 3. So we have x squared, 3x, 3 times x is 3x, and 3 times 3 is 9. These two right here give you the 6x from right there, and then 3 times 3 gives you the 9. So because that pattern holds true, we can write it like this. That means that because half of 10 is 5, and 5 squared is 25, we can write it like this perfect square here. Because half of 4 is 2, and 2 squared is 4, this holds true in this pattern, so we can write it like that. Here, it also works with negatives. This can be written like that, so with x minus 4 and x minus 4. So you get x squared. Negative 4 times x is negative 4x. Negative 4 times x here is negative 4x. And negative 4 times negative 4 is a positive 16. So because half of negative 8 is negative 4, which will be right there, and negative 4 squared is 16, the pattern fits here, and so that means we can write this as a perfect square. Now, remember that an equation of a circle is really essentially two perfect squares. And last week we talked about how you might see them written like this. So this could be like x squared plus 4x plus 4. That is another way to write this. Okay, because you could just, if you multiply that out with the box, you'd end up with that. Half of 4 is 2, 2 squared is 4, so it's x plus 2, because whatever half of that is what goes there. Plus, here, you could rewrite that like this. X squared, minus 10, that should all be y's. Y squared minus 10y plus 25. That should be a y too. There we go. Because an equation of a circle has an x and a y in it. So that would be y squared minus 10y plus 25, because half of negative 10 is negative 5. Negative 5 squared gives you the positive 25. So this is just another way to write that if you multiply out each of these perfect squares. So this right here is a different way that you might see an equation of a circle, although it's more helpful to see it written like that. Sorry. So with that in mind, these were set up, These were set up to work out perfectly like this, However, it won't always be like that. In fact, it most often won't be like that. So if you see it written like this, they're already set up for perfect squares. You can just write them like that. However, almost all the time, they won't be set up for perfect squares. So we're going to have to use some math magic to make that happen. And that is what we're going to do right now. So here you have this example. Notice that the x's and the y's are all mixed up together. The first thing that we want to do to be able to write it like this, where we can easily see what the center is, here be -2, +5, and the radius here is 4, because the square root of 16 is 4. In order to get that information, we need to write it like this. And so the first thing we do is we separate it into all the x's and all the y's. So let's divide it out into like 2 separate groups. So we first have the x group. So I have an x squared, and I have -4x. And then I'm going to leave some space here, and then I'm going to start writing my y's. I have this plus y squared, and I have plus 10y. And the only thing left that I haven't split into one of these 2 x's and y groups is this -7. Now that doesn't belong in either group. It's not an x term. There's no x. It's not a y term. There's no y. So what I'm going to do is I'm actually going to add it to the other side. I'm just going to get rid of it over here. And so that cancels out. And so now I have this equation of x squared minus 4x plus y squared plus 10y equals 0 plus 7 is 7. Now what I'm going to do is I'm going to think, what would have to be right here to make this fit this pattern? Well, in this pattern, I always take half of this number, and then I square that to get this number. So half of -4, so -4, half of that would be -2. And then I square that -2, and I get a +4. So this really should be a +4 in there. But if I add a 4 on this side, I also have to add a 4 on this side because it's an equation. So I'm also going to say +4 over there. Okay, so this gets evened out with that. Now here, what would have to make this a perfect square? So to make it fit that pattern, I would take half of 10, which is 5. So half of 10 is 5. And then I square that, and I get 25. So that would be a +25. But I can't just add a 25 on that side without also adding a 25 on this side. So now this is very helpful because in doing that, I have 2 perfect squares. This one, fitting with this pattern up here, turns into x minus 2 squared. Remember, this number is always just half of that. Plus, and this is going to turn into x plus 5 squared equals 7 plus 4 is 11 plus 25 is 36. So now I can see, now that it is in this wonderful and most helpful form, I know that the center is going to be a +2 and a -5. Whoops, I did it again. That should be a y. Sorry. And the radius is going to be the square root of 36, which is just 6. So by completing each of these perfect squares, we can write it like this, as long as we also, when we complete these squares, we even it out over here. And we can write our circle in this really helpful form. Let's try it again. So the first thing we do is we split all of the terms into a group of x's and a group of y's. So over here, we're going to have x squared plus 6x, and then we'll leave a little space so that way we can finish that perfect square in a second. And then we're going to have our little y area here. So y squared minus 8y. We don't need the 12 because that doesn't fit into either of these, so we're just going to move that to the other side by subtracting it on both sides. So when we do that, 36 minus 12 gives us 24. Now, we're going to think what would complete this perfect square right here. And if you take half of 6, so 6, half of that, divided by 2, you get 3. And then you take the 3 and you square it, you get 9. So that should be a plus 9. And then you would add 9 over here. Because in an equation, you can't just add 9 to one side. So now you have this just turns into x plus 3 squared, following that pattern. Half of 6 is 3, so that would be the 3. Now let's try this over here. Half of negative 8. Move that up a little. Divide by 2, that's negative 4. Negative 4 squared is 16, so that and there needs to be a plus 16. So I also add 16 on that side. So plus 9 and plus 16 matches up with this plus 9 and plus 16. Now this is set up to also be a perfect square. So I have y minus 4 squared equals 25. Well, 9 and 16 gives me 25. 25 and 24 gives me 49. Now that my equation looks like this, it is a whole lot easier to know that the center of this circle has moved 3 to the left, so now it's at negative 3, and 4 up, so now it's at a positive 4. And the radius is the square root of 49, which is really 7. And that is all for this video. It was a little bit longer. We did 2 examples because I know this is a little bit, there's kind of a lot involved with it. But go ahead and try the practice and see how you do. Feel free to come to our Google Meet and I can answer any questions, or you can email me and we can work through it together. Thanks. Bye.